Okay, kids, this is the second page of the triangle review for your test coming up on Friday. So whatever day you're listening to this, the test is on Friday, whatever day that might be in your life. Okay? So we have a couple of things. Number 11 here, right? This is the second page, so hopefully you've already done the first page, or you or whatever, right? Whatever. So number 11, hopefully you recognize this as being an exterior angle problem because we are given some information about this exterior angle. And hopefully you remember the formula, how an exterior angle relates. Well, it relates to the sum of your two remote interior angles. So hopefully you're able to generate this equation. Okay, we always have the exterior angle first, and then we have the sum of the other two angles. So now we have some algebra that you're going to need to solve with all of your amazing algebra solving skills. Okay, we have some like terms, right? X and 4x, that's going to be 5x. And we have a plus 12 and a minus 9, which is a plus 3, right? So we combine our like terms when we need to in order to solve this for x. So I'm going to minus 5x from both sides, 2x on the left. I'm going to add 15, right, because we're doing the opposites. 2x equals 18, so I'm pretty sure that x equals 9. Okay, so we can put that down here in this slot, that x equals 9. And now we're going to find some measures. Angle BCD, right? So we start at B, and you go to C, and then you come to D. So this here is angle BCD, also known as just angle C. Is x plus 12, which is 9 plus 12, so this is 21 degrees. And ABC, well, ABC, here's A. ABC is your exterior angle. Exterior angle. So we're going to plug 9 into your exterior angle formula. 7 times 9 is 63. 63 minus 15 is 48 degrees. Okay, so once you plug it back in, now our answer has a degree on it. But x is not a degree, x is a number, x equals 9. Okay, number 12, triangle Mr. H, MRH, has midsegment BE parallel to RH. Okay, so let's draw that for a second. And this is what it looks like. What is the length of RH if BE is 6W minus 5? So let's plug that into here, 6W minus 5. And RH has an equation of 9W plus 7. So 9W plus 7 is not the length of RH, that's the equation for RH. So now we need to solve for W and then plug it back in. Well, once again, we said that this was the base, right? So this you should recognize as a midsegment problem. So the base of 9W plus 7 equals 2 times the midsegment. And in this case, our midsegment is 6W minus 5. Base equals 2 times midsegment. So our base length equals 2 times the midsegment length. And now we're going to algebra in order to solve this for W. So we're distributing the 2, right? Multiply both of those things by 2. I see that 12 is bigger than 9, so I'm going to move my 9W to the right side, which means I am moving my 10 to this side. And I get not a pretty number, it looks like. Yuck. But that's okay. W equals 17 divided by 3, which is 5 2/3, or 5.666666667. Okay. So now I want to figure out what the length of RH is. So I can probably multiply this in my calculator. 9 times 5.6666667 plus 7. I bet you this is going to be a whole number, and it is. RW turns out to be 58 units long, or sorry, RH is 58 units long. Okay, so if you're plugging this into your calculator and you have that many decimals, literally put in that many decimals so that your calculator doesn't round and give you the wrong answer, because there's no decimals there. Okay, determine if a triangle can have sides of the following lengths. So this is using the triangle inequality theorem. So we need to know that the sum of the two smaller sides must be greater than the larger side. Okay, so that's what we're testing here. Is 14 plus 18 greater than 32? Let's see, 14 plus 18, calculator says 32. So this is a no, it cannot, because 14 plus 18 is not greater than 32. Okay, so these triangle cannot have sides of 14 and 18 and 32. Doesn't make a triangle. And the next one, okay, I'm going to take 13 and add it to 15, right? The two smaller sides, do they add up to be bigger than 27? That is the question. And yes, 13 plus 15 is 28. So this one is a yes. 13 plus 15 is in fact greater than 27.
What about 15 plus 27?
And ooh, the challenge. So we're going to use this picture over here. We're told all of these things are mid-segments. Okay, so there's our picture, and all of the smaller ones in the middle, MS is a mid-segment of ED, right? Here's the base. Every mid-segment has a corresponding base. So let's see what information we're given. And all of these are independent questions. None of them have anything to do with the other ones. So number 14 says GS is 3x plus 7. Okay, so GS is 3x plus 7. And SN is 4x minus 3. Okay, so the geometric relationship here is, because this is a midpoint, these ones are going to be equal. So we will make our equation by setting them equal. Okay, and we're solving for x, and it looks like x equals 10. So if x equals 10, Gn is, plugging 10 back into here, 3 times 10 is 30, 37 plus, plugging it into here, 40 minus 3, 37. 37 and 37 is 74 units long, is the length of Gn. Okay, DEG angle DEG is this one. This is 88 degrees. An angle G is 2x plus 10. And GSM is this one right here, is 3x plus 2. What is x? So looking at this picture, right, I don't have a whole lot of information. In fact, it looks kind of scriggly and scrunched in here. So let me see, what was this angle again? This angle was 3x plus 2. So in order to solve for x, we're going to have to make some type of an equation, right? So hopefully remember that if this angle is 88, then this angle is also 88, because those are corresponding angles. Okay, and now that I've made that transfer, I can add up these three angles to 180. Now these are three angles of a triangle. So I've got 2x plus 10 plus 3x plus 2 plus 88 equals 180. Okay, so because this is a mid-segment, it's parallel. The mid-segment is parallel to the base. So these 88 degree angles are corresponding angles, which is why we're able to make this equation. So combining like terms, 3x and 2x is 5x. And 10 plus 2 plus 88 is 100. Okay, so we'll minus the 100 from both sides. 5x equals 80. And if my division is okay here, 80 divided by 5 is 16. And it just said what is x, so x is 16. And that's that. Okay, 16, ds is 25x minus 4. So that's here, 25x minus 4, right? That's a mid-segment. And gm is x plus 44. X plus 44. What is the length of GE? Okay, so if we have the relationship that the base is 2 times the midsegment, that means the midsegment is half of the base. Yes? And M is also a midpoint. So yes, we could have this be x plus 44 and this be x plus 44 also. So these equal 2 of those. Or we could just say that this much, x plus 44, equals 25x minus 4. Right? Because SD is half of GE. Well, GM is also half of GE because M is in the middle. So I'm going to make a more straightforward equation by putting 25x minus 4 equal to x plus 44. Okay, so remember, GM, this is half of your base. Well, your mid-segment is also half of your base. So both of those things are half of your bases, then they are equal to each other. So we'll subtract the x, 25 minus 1 is 24. We'll add the 4, 44 plus 4 is 48, and x equals 2. So what is the length of GE? Well, GE is 2 GMs. So if we plug 2 into GM, 2 plus 44 is 46. 2 times 46 is 92. So GE is going to be 92 units long. Okay, and our last one says challenge, 10 points. So let's see what it's asking us to do. SD is this distance, so SD is a mid-segment, and GE is its base. So here's your mid-segment, and there's the base. Mid-segment goes with base. Angle GSM is here, and angle N is 4x plus 8y. So these are corresponding angles, so they are equal. And SD, GE is the base, GE equals 2 SDs. Okay, so let's write that down and see what we can gander from these equations. So those are our equations. We have a base, 2x plus 17y, that's GE, equals 2 mid-segments, which is your x squared plus 8y, that's SD. And then we have our 2 corresponding angles. So let's think about what we can do here, maybe to simplify this a little bit. Well, let's let's get rid of these parentheses over here. We can do that. 2x plus 17y equals 2x squared plus 16y. That might be kind of promising, because I have a 17y and a 16y. Right, so if I combine those, if I bring my 16y over to this side, I get 1y, right? 17 minus 16 is y. Let's move our 2x over to the other side also, because I have a feeling we're going to be doing some substituting. Okay, so I have solved that equation for y. And 2x squared minus 2x. Is the equation that goes along with y. Okay, so I can do a handy thing and plug that into here now. Okay, so this is going to be kind of messy. Maybe it's going to be messy. Maybe it'll be okay. But let's see what happens. All right, now that I have substituted, I noticed that there was another one. There's another y here, so I've replaced both y's in my equation. So now let's get to doing all of our substituting that we can and simplifying and stuff. So I have 10x squared minus 10x, 4x plus, here we have, this is 16x squared minus 16x. Okay, so this is 5 and 10, that's 15x squareds minus 10x equals 4. Well, I can do some simplifying here, huh? 4 and minus 16 is minus 12x. Okay, so, that's interesting. I have no numbers going on here. So let's see, what can I do? Let's just get our x squareds together. I see 15x squareds here. So I'm going to subtract 15x squared over to here. Okay, in that case, I have 1x squared. You know what? I'm just going to move my 10 over also. Let's add 10x to this. Right. It sort of has the makings of a quadratic, but it's missing a number part. Negative 12x minus plus 10 is minus 2x. And I get to here, 0 equals x squared minus 2 times x. So from algebra, you might see that both of these have a common multiplier, right? Both of these terms have a multiplier of x. So what I'm going to do is I am going to common factor. Since they both have a common multiplier, I am going to, in essence, divide both of those terms by x. Right? So if I take 1x away from here, then I just have 1x left. And if I take this x away from here, I have a minus 2. Okay? So do you see what happens here? If I were to distribute, x times x is x squared, x times minus 2 is minus 2x. Okay, so this isn't a quadratic style factor, this is a common multiplier style factor. But I still have the same idea, is that if I have two things multiplied together to give me 0, right, I am multiplying two things together to give me 0, then either this has to be my 0 term, or this part needs to be 0. So I have two solutions to my problem. I have x equals 0, or I have x equals 2. Right? Two solutions. But I'm not even done, am I? No, I'm not. So if I come back over here, what if x is 0? If x is 0, then y is 0 also. Yes, would you agree? That if x equals 0, then 2 times 0 minus 2 times 0, that's still 0. But what if x is 2? Then y is 2 times 4 minus 4, right? When I replace x is 2 in both of those. Sorry, that's a 2, not a 0. Sorry, I shouldn't have circled it. Y equals 8 minus 4, which is 4. Okay, now since these are lengths, right, these are all lengths up here, the length of GSM, the angle, the length of SD, probably 0 is not going to be a very fun thing to do. So I'm going to go with my two solutions, x equals 2 and y equals 4. Okay, yeah, there's a lot. That's why this was a challenge problem, because it takes a lot of algebra after the little bit of geometry in order to solve this one. Okay. So no, the one on your test is not that difficult. It does not have a quadratic, I believe, but you will be making a system of equations and solving it using substitution. Okay, there's page 2. Good luck, I guess. Okay, bye.